Now this video deals with looking at actual problems involved that we convert to use right angle triangle trigonometry. So if we haven't got a diagram at any stage, you got to make sure you draw one. So you're getting a visual representation and know which sides you're dealing with in relation to the angle that you've been given in the problem. So this time we're talking about an angle of elevation from Amanda to the top of a tree is 51 degrees 34. So we're looking, there's Amanda, the angle of elevation. Remember, we look from the horizontal and then look at the angle that she has to look up. So, okay, so it's how far up it goes, and it's 51 degrees 34 minutes. Now, she's standing 5 meters away from the tree. How tall is the tree? Now, we're sort of approximating here because, yes, we haven't taken into account how big Amanda is, but we can't do much about that. We've given no data there. So we can only do our best with what we've got. So, we want to have a look at the two sides we've got. We've got our opposite side, and we've got the adjacent side, which means we're going to use the tan ratio. So tan of that angle would be x on 5. Now, if I haven't got that diagram, that's going to make it a little bit hard to try and distinguish which ratio I've got to use, the sine, cos, or tan. But once I draw it up, I can see where my right angle is, which one would be my hypotenuse, and my opposite and the adjacent. So throwing our calculations in, we're able to get that. And really, it's about setting this up correctly. If we set this up correctly and get the correct ratio, everything else should go pretty well unless we make a simple error, which we're trying to avoid. This time we've got a plane leaves Sydney and flies on a bearing at 235 degrees for 500 kilometers. Well, 235 would be around 90, 180, and then 235 there is that angle. There's 35 degrees away from the 270 degree marker there. So, and it travels for 500 kilometers. How far west is the plane of Sydney is the plane? So how far west would be where the x is there on that side. So again, notice how we've been able to draw up a nice right angled triangle to solve this. And we've got the adjacent side over the hypotenuse, so it gives us the cosine ratio. So x would be 500 lots of cosine 35, which is 410. Now notice, we haven't talked about it before, but notice that that starts to become lower, which it should do, which means that cosine of 35 is a fraction, and that should be the case. And we'll talk more about this later. Why would cosine of an angle be between -1 and 1? So it's always going to be between minus. It's always going to be a fraction. You can start thinking about that, and maybe you'll come up. You'll have the idea when we actually get to that. I to play around with that a little bit more. This time we've got a bird which is perched on a 10-meter tower. It's watching a worm on the ground. It has an angle of depression of 67 degrees 20 minutes. So that's its angle of depression. The tower is 10 meters tall from where it is. So what I've done here is play around. I've got basically I'm forming a triangle up here. That I'm looking at that being 10 meters there. How far does the bird need to fly down? Well, assuming it goes down in a straight line, that would be the hypotenuse. And that's going to be our other angle. Because again, with these two are the horizontal, which means they're parallel. So we're able to look at this one and go, well, I've got a 10-meter side here, which is the opposite of that one, of that angle, and I've got the hypotenuse, so I'm going to have the sine ratio. So again, you're seeing that x would be equal to 10 over the sine, so 10 over sine 67 degrees 20, which gives us 10.8. Which makes sense. It's a little bit more than 10, which is good. Question 8 here. Lee starts a bushwalk at Katoomba by walking 4 kilometres due north. So walk 4 kilometres due north, so that's Katoomba there. And then walks west for 5 kilometres. So walked in the west direction. Because again, that's going to be north when we look at our our angles there. So what we want is, what's Lee's bearing from Katoomba? So when we look at that, it's like, where is Lee and where's it from? So it's from Katoomba, and that's where Lee is now. So that's the angle we're looking at, and this is where we've got to be careful of the language of saying, well, what's the bearing? And this is one of the most poorly done parts of language in mathematics. So where are you from? And well, it's from Katoomba, so that's where we're looking that direction for Lee. So we've got two sides. We've got 4 kilometres and 5 kilometres, which is the adjacent and the opposite. So that's where we get tan of theta is 5 on 4. So we take the inverse tan of 5 on 4 and get 51 degrees there. Now, what we've got to look at is what's the bearing? Well, if that's 51 degrees and 20 minutes, or if we wanted to round it down to just 51 degrees, then the bearing would be, so this angle is going to be 51. Now remember, the bearing's got to be from 0 around here. So that's where we're going to get 360 minus 51 if we just take it there, which would make it 309 if we ignore the minutes. So that's where we get 309 degrees there. Now, the bearing of Katoomba from Lee. Now, if that's going to be if we're going to have that, then what we want is Lee's basically looking back at Katoomba, and what direction does Lee need to look back at Katoomba in? So we got 90 degrees there. We need this angle. Now, if that's 51 degrees, that would be 39 degrees, and that's what we've looked at there. So if we just said 51 degrees, 90 minus 51 would be 39, because the two have to add up to be 90, because that's a right angle there. So that's 90 degrees there. So the bearing we want is 90 degrees plus the 39 degrees, which is going to give us 129 degrees as the bearing that Lee's looking has to look back at Katoomba. In this one, circle radius 30 centimeters, has a chord. Now, chord is a line that goes from one side of the curve, one side of the circle to another, and it's 20 centimeters. And we need to calculate the magnitude of POM, so the size of POM, so this angle here. So to do that, what we look at, we know that it's going to be 30. That's 20 there. And we know that ON's a perpendicular bisector, so it cuts it in half. So if we're looking at cos of PON, so looking at this angle here, that would be 20 over 30. Sorry, draw the chord there. The chord there would be 20 centimeters there. Sorry, I didn't want to put it there. It's not right. So the line there is 20. That's 30. That's 30 because it's a radii, OP and OM. So that's where we're going to use cosine, which is the adjacent side, over the hypotenuse. So 20 over 30 gives us 48 degrees for this part here, which we must double for POM. So PON's there, but POM is double that because it's a perpendicular bisector. That's right angled, that's right angled. These two triangles are exactly the same. Then find the length of the chord PM. Well, we've said, well, let's use sine of 48. So again, we've worked out that's 48 degrees. So using PN over 30 and sine, we could have used tangent if we wanted to. It would work out exactly the same. So PN comes out of approximately 22.2943. Double that again, we get 44.6 approximately. This time we've got a sloping roof built so it allows enough room for a 1200mm window that requires an opening of 1260 mil. So that's going to be a 1260. Span of the roof is 6400, so 6400. So that's the length there. What angle should the roof be pitched? Well, we want the angle there. We've got the opposite. Even though it's up there, we really just have this side, which is the adjacent. So that's where we get the 1260 on 6400 and the tan ratio. And then inverse tan of the 63 over 320, because that's what it simplifies down to. And the roof needs to be pitched at 11 degrees. In this case, we've got an aircraft that flies due south for 100 kilometers and then west for 250. Find the distance and bearing of the aircraft from the starting line. Well, two-part here. We've got two sides, and it's in a right-angled triangle. So we can use Pythagoras. Don't forget Pythagoras. Whenever we have trigonometry, Pythagoras is going to get involved because it's going to be doing with right-angled triangles. And then we've got to find the angle here. 100 over 2, sorry, 250 over 100, because that's the opposite and the adjacent. So make sure we get them right. Gives us an angle of 68 degrees. So that's 68 degrees. We've got to add that to the 180 degrees to get the bearing, because we've got to go from north each time. Remember, north is 0 degrees. So we're going all the way round through to 248 to look at where the plane is right now. So that's how we start to put some triangles into place. Reading the questions carefully, getting a right angle triangle for our problem, and then starting to solve by getting the correct ratios and doing what the question's asking us to do.